Today we're going to be talking about another relationship between the trig ratios. Yesterday we talked about the reciprocal functions, and we talked about how the cosecant of theta is equal to 1 over sine theta, how secant of theta is equal to 1 over cosine theta, and how cotangent of theta is equal to 1 over the tangent of theta. And that was one set of relationships that we talked about called the reciprocals. Today we're going to be talking about cofunctions. So what I would like you to do is pause the video for a moment and go in and fill out this chart right here. I've left a couple of hints on some of them telling you exactly how you need to put that into your calculator. So you're going to use your calculator, and then over here fill in the last little column. So please pause the video and go ahead and take some time and do that. Make sure you can get the right answers on your calculator. So now that you've had a few minutes to go through and figure out the values of what was asked, they want you to notice that when you do the sine of 74 and the cosine of 16, sine and cosine are co-functions, get it, sine, cosine, that you get the same value. And then they point out over here that the angle that you took the sine and cosine of, if you add them up, add up to 90. Same thing in the next one. Cotangent and tangent are co-functions, tangent, cotangent. They have the same value when the two angles that you're finding the tangent and cotangent of add to 90. And then we have secant and cosecant. Secant and cosecant also co-functions, and their two angle measures add to 90. So that is no coincidence that that ends up happening. If we flip to the next page, we have a definition of cofunctions, and in this definition, it talks about the function of an acute angle is equal to the cofunction of its complement. The prefix co in this case gives us a hint about what's going on with cofunctions. So sine and cosine are cofunctions. Their angle measures add to 90. Tangent and cotangent are cofunctions. Their angles will add to 90 if they're equal. And then secant and cosecant, if the values are equal, their angles will add to 90. So in this case, if we take a look at the example, we know that 30 degrees is complementary to 60 degrees. That means that if I take the sine of 30, it will be equal to the cosine of the complementary angle. On your calculator, if you type these two in, they will be equal. The tangent of 30 is equal to the cotangent of 60. If you type these two in on your calculator, they will be equal. Just to note, when you type in cotangent of 60, you have to use the reciprocal relationship where you type in 1 divided by the tangent of 60. And then in the last scenario, the secant of 30 is equal to the cosecant of the complementary angle, in this case 60. So if we were to take this information and write it in a general form, which you see in the next section, the cosine of theta will be equal to, the sine of theta will be equal to the cosine of 90 minus theta. These two angles are complementary. The tangent of theta is equal to the cotangent of its complement. The secant of theta is equal to the cosecant of the complement of that theta angle. They ask us in the next examples to write an expression for an equivalent function using the cofunctions. So what they're asking me to do in this section is to say, What do I know sine of 70 is equal to? Well, it's equal to the cosine of 20. These two angles have to add to 90, and these two trig functions have to become cofunctions to each other. So tangent of 10 is equal to the cotangent of 80. These add to 90. These are cofunctions. Cosecant 41 is equal to the secant of 90 minus 41, which gives me 49. And then the secant of 47 is equal to the cosecant of, in this case, when I subtract 43. In the next examples, they ask us to actually solve for x. In these cases, they've given us equations that involve cofunctions, and they're saying that the secant of this is equal to the cosecant of this. If that's true and I'm using cofunctions, which I am, secant and cosecant, then when I take those two angles and add them up, the 2x plus 25 and the 35, they should be complementary or add to 90. So this gives me 2x plus 60 equals 90. So 2x equals 30. And x, of course, then is just 15. I can do the same thing with number 6. I have two cofunctions. They are set equal to each other. In that case, it means that their angles must be complementary. So 2x minus 1 plus 3x plus 6 has to equal 90 degrees. So 5x plus 5, whoops, nope, that's right, 5 equals 90. 5x equals 85, which is going to give me that x is equal to 17 for my answer for this one. For question 7, they're again talking about the cosine and sine, and they want to know what angle measure will make sine and cosine have the same value. So there's one angle measure where if you take the sine of it, it's equal to the cosine of it. So in this case, I am technically saying that the sine of some angle, I'll call it x, could be theta, has to be equal to the cosine of the same angle. In this particular case, if we use our concept of cofunctions, these are cofunctions, which means that if they're truly equal, their angles must add to 90. So 2x equals 90, and the x value here would be 45. If you wanted to go back and check that, you could type in on your calculator the sine of 45 and the cosine of 45, and you will find out that they are indeed equal.